Once again, give us a hand for your MC, John N. Gates.
All right, welcome back from the break. I have decided I know what to get my wife for her birthday this week, which is some Kendra Scott jewelry. So I learned one good thing today about on a personal note. We're going to learn a little bit more here, though, about what's going on in the cloud, more specifically the private cloud. So this afternoon, we have a panel. We have a number of rackers that are going to come up and speak to you. But first, we're going to hear from Notre Dame. Notre Dame Center for Research Computing is solving for trying to help their researchers solve world's problems. All kinds of scientific research going on, and they need computing, and they need massive amounts of it. The challenge is to provide them a cloud platform that's reliable, that works, that can spin up and scale up very quickly. The solution that they've selected is a private cloud powered by OpenStack, and Rackspace is helping run that. So let's watch a video on Notre Dame.
My name is Paul Brenner. I am a scientist at the University of Notre Dame. I'm Associate Director, Notre Dame Center for Research Computing. So the Center for Research Computing was founded with a mission to support the scientific research of the university. So whether that be trying to simulate a hurricane, designing next generation nanomachines, or whether we're designing next-generation databases and scientific gateways that allow folks from around the world to share data about vectors for malaria transmission. There's a broad range of ways that we need to bring IT and computational technology to the aid of science to make a better world.
We collaborate a lot worldwide, so we're looking for open solutions that would support this collaboration, and OpenStack and Rackspace are good partners for that.
With OpenStack today, when someone walks into our office and says, I have this idea and here's the needs, we can, on this cloud platform, within hours or minutes, have that system up and running so that they can be doing that science. The University of Notre Dame has been very fortunate to be able to partner with Union Station Properties, a very innovative co-location facility. And we've partnered to take an old train station that otherwise had kind of deteriorated from its prior function, and really work to help make that a new kind of IT node and infrastructure area. So we have a number of engineers along with our infrastructure, over 20,000 cores, multiple petabytes of data. Some of the early public cloud offerings really were most cost-effective and helpful in burst scenarios. We have a high utilization year-round, and Rackspace has been able to help us through a private cloud, RPC, leverage all of that performance that we need on the hardware within our own organization with the technical expertise they have in managing an OpenStack infrastructure to really bring us the best of both worlds.
Working with Rackspace is great. It's just great. I think we understand each other very well in terms of what is the future of cloud computing.
The communication has been excellent, the project management has been excellent, and their technicians have been available 24/7 to really help us fix our problems, to solve our challenges. So there's a much different concept of how they want to solve our problems, not find ways to fit our problems into their closed source offerings. I have the best job in the world. I get to work with brilliant faculty and help bring them tools so that they make their discoveries faster. I hope that soon some of these new discoveries, the way we do our algorithms, the way that we deploy our infrastructure, will allow us to better understand everything from the human body to a hurricane.
We are dealing with big problems, but we're hoping that we're helping the world, that we're changing the world, and this is what Notre Dame is about. We are fighting Irish, and our daily work is really changing the world.
Would you please welcome Paul Brenner from Notre Dame? Paul, thank you.
Well, thank you very much. I must start out, so I am a operations guy in terms of running the scientific computing, but I'm also a scientist in the computer science department. I also teach, so at any point in here, if I call you out, I apologize. If anybody's students, I see a hand quasi go up in the corner, I might pause. So there will be no exam. The slides are all built so that you can take them all home. You could do an at-home exam with your kids if you want, but I will not have a test for this particular. So trying to talk about what we're doing in terms of a research computing, talk about solving some of these things that need to be more dynamic. I'm going to cover a number of topics, specifically what is research computing, what is scientific computing, talk about discovery, and more importantly, heterogeneity, how heterogeneity is necessary for discovery, talk about how you fit that discovery, how you fit that heterogeneity into a private, into a public, and into some sort of a hybrid interface between those. Then I'll talk practically about lessons learned, what we've been seeing as far as opportunities, what we see as potential challenges, and where we're going with this as we move into the future. Quick numbers. So Center for Research Computing, we serve locally about 1,650 researchers, thousands of external collaborators, whether that's working directly with our HPC or through any one of the scientific gateways or portals that we run. Physically, we run about 1,500 servers in our data center, 20,000 cores, 2, 3, now pushing beyond 3 petabytes of data. A lot of public-facing, increasing number of public-facing scientific gateway, whether they be servers, VMs that they're coming through command line, whether they be very rich content gateways, whether they be gateways to, we talked about the touch environment, gateways where someone is sitting in Africa and they're logging in from an iPad or from a touchpad information that's being shared up so we can come up with better ways to fight malaria. So a very broad number of particular virtual machines, interfaces, hardware, HPC. Our team's about 40+ engineers just dedicated to supporting the scientific computing needs of our university, and we support 100+. If you took all of the pre-canned, we'd be in the 200-300 particular pieces of software. Innovation is disruptive, right? Innovation is chaotic. We know that every day at a university. We have scientists that are trying to do things different than the way we do them today. And if you want to do things differently, if you want to do things orders of magnitude faster, better, to do these discoveries, we're going to have to be open to change. We're going to have to be open not only to change, but to do things on a very heterogeneous platform. Now, from an admin standpoint, an operational standpoint, that's evil, right? So, if we could do everything on the same operating system with the exact same version of the kernel, we would all be great, and life would be better for sysadmins, and everybody will conform and will comply. For the rest of us that are trying to figure this out and do science, these are the types of things that we want. I've time and time again evangelized to my team that we want this list to grow. Now, if things fall off naturally, fine, but our given job day to day is to make sure we're not missing one of these. Is there an architecture that we're missing out on? FPGA is not up there. What are we missing that could potentially be up there? Is there an operating system? Right? Is there another platform that we have not engaged? Should we look at Ceph? Right? What other file system is not up here that we should be talking about right now? We are always trying to add those to the portfolio, not reduce them. Right? So innovation is chaotic, and we must have some sort of way to embrace the heterogeneity. Okay. Now, from a sysadmin, that's a very difficult challenge to have. Virtualization, cloud, a number of things have given us opportunities to try and address those. And that's what I'm going to talk about today, how we've tried to leverage cloud technology to embrace this level of heterogeneity with private cloud and some hybrid and some public cloud mixed in. Okay, so we need to leverage this, right? We've talked about, you saw a quick slide on the breadth of science. All right, so we need to be able to quickly deploy different VMs of different types of operating systems, of different software stacks with different security permissions. Okay, we need that in the cloud. We need that to be able to be dynamic. So I need my engineers to have portal, immediate ability within a project to create what they want, not to have to call somebody and think about standing that VM up. It can't take weeks. Hours we can deal with, minutes would be better, right? So we need this. All right, the challenge for us has been that the public cloud wasn't always a good fit. We're high utilization. See a lot of very practical people out there. If you've priced some of these public cloud offerings and you've looked at some of these other challenges, if you're high utilization, there's a significant cost involved there. Right? For me to take 20,000 cores and put them into a public cloud and run them at 85% utilization, significant price tag. Not only is there a significant price tag, but we look at some of these others, right? So if something changes, for me to move something that large from one public cloud to another public cloud, it's extremely daunting. How do you move your 3 petabytes, right, when the pricing isn't right anymore? So there's a daunting challenge there. And then we also talk about is the cloud providing what we need in terms of high performance computing? Anyone in here who's done high performance computing, if I gave this exact same talk at supercomputing, great conference in New Orleans next month, there's a challenge there. There's going to be animosity, right? Can you get high performance? The cloud's built for scale, built for enterprise. Does that fit in a high performance computing model? So there's still a lot of research going on there, and happy to talk about that afterwards. Okay, so the right answer for us, OpenStack, great community, good documentation. So why don't we just run OpenStack ourselves? Why RPC? Why partner with Rackspace? And I think all of you who have sysadmined or run team sysadminning things, you can get it functional 95% of the time. You can have systems running 98% utilization. It's that 2% of the time when you can't start up a new service and you can't figure out why, or it's crashed and there's a crisis, that is really the time where you need help, you need a friend, you need a partner in the business. And Rackspace and RPC has been excellent in filling that specific role for us, providing us so that we can run our own private cloud on our infrastructure, have that adaptability so that we can move within our own platforms, but have that technical expertise that they can help provide for us. In the academic world, this is also exceptionally important because we can partner with other folks that are running OpenStack, other universities, other organizations, share that, what we've learned, share those capabilities, hugely important as we're trying to run some of our own data centers. Okay. So for a number of users, this is perfectly fine, the black box mentality. All right, so everyone in the class, if you're not used to this one, this is the minimum. If you walk away today and your boss is like, hey, you went to what did you learn about the cloud? Here's your minimum slide. Make sure you can understand, okay, I learned there's compute instances and there's object storage and there's cinder block storage. Got those. There's something about networking in there. There's a user interface and there's identity management. Check. Walk in with this if you need a minimum. Here's your minimum slide. If you're going to run your own cloud, the minimum isn't good enough. Okay, if you're going to run your own, you need a partner and you need a platform that's open that you can work with. So you need something that looks, a little more like this. All right. So this is more what you need to be able to work on. This is what you need to be able to partner with folks with. This is what you need a level of confidence. OpenStack is something that I can share not only with bringing up new undergraduates, bringing up new sysadmins. It's something we can talk about as a community. We can educate on community, and I can see below the black box. Right? So this is crucial. And now understanding that, not only do I have access, so OpenStack gave me access. Rackspace gives me understanding. Right, so they bring to me, when I have a question, why does this particular part, why does Cinder operate in this way? I know it talks to this, and I know that there's some specific message passing, and we really don't understand it. That's where we call in our friends at Rackspace, and they do a great job of explaining that to us. Okay, so I wanted to talk, I'm a scientist, right? So I couldn't get away with talking about challenges, opportunities, some areas where we could all as a community keep working, doing some of this in terms of research. First one starts out, I stayed with more of a business. One of the big challenges to clouds still, and it was this way 5 years ago, remains so, is mobility. Right? You can go out, you can put all of your eggs in one basket, you can put them all in one particular cloud. What if that one, the business continuity is not there? One of the reasons we chose OpenStack is it gives us some level of security. That code's out there. It gives us the liability that someone fails at the top, we still have other people that can pick up the mantle and carry the torch. All right, so that was one of ours. Price lock-in, terrifying, right? I'm going to give you a great deal for this year. I'm going to give you a great deal for 3 years. It's hard to convince your CFO to do a contract for 5, right? So the CFO only wants to pay for 3, maybe 1. All right, so you're going to go get a great deal for 1. You're the IT person who just moved everything in, and in year 2, the pricing, that great deal's not there anymore. They know you're locked in, right? I think all of us have done, particular projects there where that is, terrifying, and you watch that bill and you know you're powerless to do anything about it. All right, so that's terrifying. We still need to work at that as a community and what that means in the cloud moving around. And then capability and service. You put all your eggs in, and they've got the best features in the world, right? We can make an argument today, any of the cloud services out there, the main public cloud providers, who is the best? But what's that argument in 3 years? Right, who's got the best services? I don't know. They will tell you whichever, but I don't think any of us can guarantee that. So if you want to make sure you have the best capabilities, so you're outbeating your competitors, we need mobility. All right, so that's the number one what I would say research, development, community area that we need to keep pushing to make sure we evolve as a community. All right, the second item I want to mention is federation. I'll talk very briefly about this on another slide or two, some projects we're doing, trying to learn how to federate our private cloud to other clouds. But I think this is important. I was talking with some folks at lunch where we talk about identity management and those types of things, dual authentication. You know, I need to be able to get to my cloud as Paul at Notre Dame, at Paul at Facebook, Paul at Gmail, Paul at Rackspace. Maybe I need to go in as 2 of those, you know, best 3 out of 5. Ways we can start authenticating so I can getting access to these resources for myself, for my collaborators, and for different levels of authentication around the world. So we have a lot of work, I think, still to do in federation and security as it has to do with federation. And then network. And I'll have one slide here that I'll talk about the network, you know, and where I think we have, you know, a great opportunity in the academic. And then the commercial, really where you need to spend some time thinking about where does your network take you if you're going to use private, hybrid, public cloud infrastructure. Okay. So we're fortunate to have a partnership that has about 250 some odd universities. Great. There's 60 corporations, 70 some odd government agencies, called Internet2. Great organization. It's nonprofit. Has one of the biggest network backbones in the country. Rackspace is a partner working with Internet2. All right, so any university in the country can now, through Internet2, get access to Rackspace. That's hugely important for us. To make this hybrid cloud happen, I need good bandwidth. I need low latency. You know, I can't say, hey, I have a route to Amazon or I have a route to Azure or one of these. We all have a route. What's your bandwidth? What's your latency? How many hops are you going to hit along that? And how reliable is it? Right? If any one of those is in question, your entire infrastructure could be in question if you're trying to have some sort of a hybrid or a private cloud approach. Right? So you've really got to think about the network if we're going to talk about spanning those 3 things, private, hybrid, public. All right? That network is crucial. You can do it all just public, totally off your network, you're in pretty good shape. 100% private, but if you're doing anything in hybrid, really have to think about that network. Okay? And then your international network. Okay. The federation, a couple of different projects going on, but I want you to think about and make you aware that OpenStack is being engaged, universities, nonprofit corporations across the globe. It's really exciting for us at universities where we partner. So ICT Biomed, University of Notre Dame, friends at Poznan University in Poland, friends, hospitals in India, Sweden, Johns Hopkins. We're all standing up OpenStack and seeing where we can have them talk to each other to share biomedical data, help researchers get access to that. Great opportunities there for OpenStack and things we can do to federate. High performance and high throughput computing, specifically high throughput. Our friends at Wisconsin we're working with closely. So some of these high throughput, if you've ever talked with folks and you need to run lots of simulations, because OpenStack is open, we can write stuff directly into the API and the kernel. Some really exciting things we can do reaching in to that open source code. And then last, any of you guys that are interested in the God particle, you say, well, you're from Notre Dame. Well, it was not discovered at Notre Dame. We did have physicists on the team, yes, but you know, there's arguments. It's a worldwide collaboration of folks based, you know, the particle accelerators are CERN in Europe. But that discovery in the past year, the folks doing that high energy physics, petabytes and petabytes and petabytes of data coming out of the accelerators, trying to figure out how we federate with OpenStack that around the world. CERN's committed to doing OpenStack as their primary infrastructure. How do we federate that data around the world? So a lot of cool stuff going on with OpenStack. Okay. One last slide, and I think I'm right about on time. They told me not to let this turn red, so I'm still good. I keep looking. 3 things. The network is critical at every level. Those in the room have tried deploying OpenStack, even within your own OpenStack deployment. Setting up all the appropriate VLANs, getting everything configured is challenging. If you have some excellent network engineers, I would say you may try it by yourself. If you do not have the best network engineers in the world, you need to find some, and Rackspace has quite a few of them. Network is essential. So network's essential within your own, and then of course, as I just talked about, if you want to do a hybrid, you've got to have a good network if we're going out into the WAN, right? So wherever you're trying to tie into a public cloud offering, whoever that public cloud offering might be. Second, capitalize on the benefits of an open source community. It's a democracy in some regards, right? Democracies are messy. Democracies are bureaucratic. Don't get caught up in the hype around, oh, it's, all horrible stuff, they're holding us back, it's bureaucracy, or vice versa, the hype on the good side. Every great idea that's ever thought of will go into OpenStack because it's open. It's obviously a reality somewhere in between. Pay attention to the new features you want, pay attention to who's developing, and pay attention to the major players on the OpenStack leadership. There's multiple corporations, and figure out where they're going. If you're going to invest, if your university, if your corporation is going to put it into OpenStack, make sure you're paying attention to the community and embrace that community for what it is. Okay? And then the last is this heterogeneity. It's obviously very different for me. Everything is about diversity so that we can have great innovation. It's about disruptive technology. It's about new things, everything new that I could possibly bring to bear. That's terrifying and may not necessarily fit into every corporate business model. But I just ask that you very carefully make sure as you're trying to standardize, as you're trying to simplify interfaces, as you're trying to make sure that all of that fits within your corporate security and IT mold and et cetera, that you do not limit innovation. Make sure that you plan to have heterogeneity. Make sure that you plan to make sure that your university, that your corporation has the ability to make discoveries, because all of us will benefit from those. So with that, I just went red. I appreciate everything. Thank you very much, and I'll be happy to answer questions afterwards.
Thank you, Paul. Thank you.
Thank you very much.
I am so proud to see OpenStack doing what Paul just described all over the world at research institutions. When we launched OpenStack a few years back, we knew it had potential. We knew it was a big deal, but it's so cool to see it making its way into all kinds of research institutions and scientists using it and students